So the big picture for this lesson is linear function applications. I think this is a really effective example in the lesson explaining about how to model with a linear function and whatnot. I want to focus here on constraints and domains. Let's say we're driving to LA. So if you want to model it with distance and time, usually use distance equals rate times time. And let's say you're driving an average of 70 miles an hour, so distance equals 70 times the time. Seems pretty straightforward. And the thing is, you can model this with a line because it's a continuous drive. In other words, you're not leapfrogging distances. You're always going to be some distance away from LA, and you're not going to have any gaps in between. If you were going to have gaps in your distance, you're disrupting the space-time continuum, and that would not be good. So let's look at a different example. Okay, let's say you went to the dollar menu for a restaurant, and you're going to see how many dollar menu items you can eat. So you're going to do cost as the amount of items that you buy. So cost equals, and we'll just call it $1 without tax, times the number of items. Well, in this situation, you can't get fractions of items. I mean, if you go to a restaurant and you try to order half of a dollar item, they're going to laugh at you. So that you're going to have distinct points. And each of these would be $1. So let's say this is $1, $2, $3, $4, $5, $6, and so on. So the domain here is going to be different than the domain for the driving situation. You're going to have a continuous line here and distinct points here. So let's look at the domain of each a little more closely. So let's say it's 350 miles to LA. So the domain is going to be the time. That's the independent variable. And the dependent variable, or the range, would be the distance. So when are you going to get to LA? 350 divided by 70. That is going to be 5. So 5 hours. Your domain, so t is an element of the real number set such that 0 less than or equal to time less than or equal to 5. So this model d equals 70t is only valid between 0 and 5 because you're not going to drive more than 350 miles to get to LA. It doesn't keep going. So this is what's called a constraint, a real-world constraint to a modeling problem. So you can't just have this function go on forever in the real world. Eventually you're going to get where you're going. Now let's look at the example with the dollar menu. Well, if you're doing 1 through 6, and then you're going to continue on, I mean, you're not going to eat these dollar items forever. At some point, you're going to get full. Let's say you bought 8 dollar menu items. So your domain would be the set of all these numbers here. 1, 2, 3, 4, 5, 6, 7, 8. So notice how different this looks compared to the continuous model where you have inequalities and such. Well, here it's just a set of integers because that's what fits the situation. And it's still a linear application, but using a line doesn't really make sense because you have distinct points and nothing in between. There's no 2.5, there's no 3.1, whatever. This is what works for the situation. So this is the domain. So that's the big picture for this lesson.